So I wanted to explain something to all of you. So, with 100% infill, pretty much that's the 100% maximum calculation based off of what it wants to do. As you can see, I'll try and get it better aligned for you. If you are above maximum, it will try and purge out. It might string and everything. Yes. Now, as you print, you're going to notice the quality shift too. You got strings, yes, you're purging. You can see where the material is pressing and pressing and pressing too much material each shot. So, this is a calculation based off of a time factor where the longer time that you spend in that same percentage of flow, which might even be a 1% difference to a perfect value, where you have just the right amount of material to put down plastic. Now, if we go here, change this again, we want to see the change over a period of time. So, if I go over, I'll try my best here. This is really difficult, mind you. I need to get a better camera. You can see right here where the line is, too much purged out. So that told me, with all the strings too, that I have too much of a flow value. So right now, we're just trying to get just to say the maximum amount only. See that string? And we leave it for a bit because we need to make sure that that flow value is going to cause us the perfect amount of press on each individual layer. So we just want to make sure, and you could plainly see the part being printed with my nozzle. I like this nozzle type because it allows me to actually see what is really going on and why something might have failed. Because I don't have a very big gap wide area for a failure to actually occur. It's just going to happen. So you guys are going to see over longer stretches of time that the part's going to improve in quality. But why is that? Well, if you're pressing too much, your part also does become wider. And this might make you think steps per millimeter are off. Now, if we can calculate flow out as a factor in this situation, then we can deal with steps per millimeter easily. Now, each steps per millimeter is a different equation based off of the system itself. The slicer does not know this, so it tries to translate it to a real part, and you kind of tell it what to do. If you think about it, 100% flow should literally be 100% and nothing more and nothing less. I like using 100% flow as a test value, because if we still have some buildup as we go, we might just need because it's a constant sent value. So if we're constantly sending a little too much, we're backing up the nozzle, which actually can cause extruder jams. And you might notice I'm printing at 280 degrees Celsius with 90 degree bed in order to remove any factors that might cause me to skip, damage my system, or clog it. So what I'm doing is making sure that I melt through it rather than anything. And you can see the quality. As I start to lower my flow, I'm getting better walls. But why does that actually happen? Well, too much press makes it wider. And remember this, we start from the bottom and work our way up, rising each time, which means that the same amount of plastic should theoretically be given over and over and over from start to finish. Now, this is the part that I want everyone to see, because Z offset can change, no problem. You could print on so many different values of Z offset based off of your flow. And walls will begin to look so much nicer as well as you start to get towards your better flow value. And your flow value is over a period of time. So you can tell how I'm just leaving it as the flow value and then letting it print, and I'm watching for strings to be removed, pressing to be pressed. Still have a string, but we want to find that ever so perfect value. That's all I'm looking for, is that ever perfect value where we get a proper consistent extrusion, but quicker. Because the faster we go, the less material we actually need because of the backup pressure caused by shoving the filament constantly. So we reduce that in the amount of flow that we give. And flow is a percentage based off of your E-steps. Because if you actually wanted a nice test, put 100% on your flow and then do E-steps, and then go into your flow and put 125% and ask for the same amount again. You're going to get 125% of whatever you asked. So that's why I have gone through and I've noticed that this will increase your part quality exponentially, because in general, I won't fail because I'm calculating the flow right now in order to keep printing constantly, perfectly, as I keep going faster and faster and faster. Have you ever wondered they use LiDAR scanners on 3D printers to scan your flow and then your first layer? Is because of that calculation right there. If you have too much, it might even make wobbly lines and everything. You can see purge line too. I make it drop a huge dot of plastic so that I can actually print. Now that causes a backup in pressure so that by the time you move over to print, you instantly eject that plastic and then move around, retract, you pull back that backup. Now that I think is the main point to all of this, because I use the same retraction at the same exact values for every filament, and I just tune my flow. So the flow is based off of a percentage of the backup in it too, because if you could get that perfect backup every time on each filament, you should use the same retraction. So we basically have this. The part quality went from really bad, actually, to really nice. It's actually not that bad. Now, we could tweak this more, yes, but I want to see the actual values based off of this, because we could only go so far, right? So, if you notice, 100% should be 100% and nothing more and nothing less. If you have more, you get problems. If you have less, well, you'll have under extrusion. Now, these are just minor increments based off of your flow that are going to build up as a backup pressure. And you can totally see what it's doing and how it's actually reacting as I'm changing the flow as I'm printing. Because remember how I said you could print at any Z offset, squish it down. As long as you can get a print going, eventually you're going to see the way that your backup is implied towards the real world physics of the print, rather than a theoretical version of the print. And I think that's where teaching tech is trying to come off of, and most of these guys are trying to come off of, where your flow, yes, when you do the teaching tech, it's theoretical, so we'll get you close, which I honestly use teaching tech to get close, but then honestly, this is the best value rate, that the best way that you could possibly find your values, because you could see where I'm reducing my stringing to nothing, because I'm not causing a backup anymore. I'm only sending what I need. And I think that's where it draws the line down to. How much do you need, and are you sending the exact values that you need? And yes, this is a 2020 extrusion, but I'm just using it as a marker for my flow because of 100%. This is being used at that, and I want to take care of my stringing. So, stringing, as you can see, the only thing, the worst part is, stringing is a lie for retraction. What's this? I'm reducing my stringing based off of flow. But then at that point, doesn't that mean that retraction does not need to be changed? Because I'm not backing up in order to string anymore, and this is PETG, so PETG is very known for stringing. The problem is, with PETG, it's a thicker material and it has a hard time coming out of the nozzle, so it likes to back up quickly. Flow seems to be very efficient at reducing the backup to get perfect results when dealing with PETG and other materials. And I always use the same retraction values. So if you could see where I had a lot of stringing and backup, I don't know if it's completely possible to see that. Probably is. There we go. A lot of stringing and retraction problems. But then you start to notice up higher, the walls get really shiny and nice, and there's not much stringing going on. Yes, there's a blob here and there. That could be fixed through flow. It's just smaller increments, right? And that's all we're doing. We're basically fixing the extrusion value to what we actually want and how much plastic we actually require, because the printer does not know this. We use 100 millimeters so that we could signalize a percentage value based off of this. And that's where most people are going wrong. I've seen it. I've dealt with it. I've fixed it. And you can see where my walls are getting better and better and better as time goes on, because that's how it's working. Because the more plastic you send, the more you're backing up. And if you send just the right amount, you're going to get just the right amount of walls, just the right amount of print, just finish the print and get it done. You won't back up by the time you hit like 150 millimeters up. You're going to have just the right amount from start to finish, and that's going to be that. So, hope some of you guys find this information a little bit more understandable, and the fact that I'm going to run the tests and show you the physical results rather than just tell you and leave it at that. I'm going to actually show you what is implied when we're looking at a 3D printer, and how do we get the best quality and the best values, and even how do we print faster. So if you tune in with me next time, we're going to look at basically how it's really thinking, and the way that this flow value actually comes at you through the slicer, and why it becomes a little bit tricky when working with your flow. Because retraction is, I don't change retraction. I don't think I've ever changed retraction. I think I changed it once and that was it, but flow I change a lot, because each filament has a different viscosity, which means that it comes out easier or harder. If it comes out harder, your best bet is to lower the flow. And if it comes out easier, you might just be purging it all out, and then by the time you get up, you have nothing left. So I would suggest watching out and on how your flow actually is involved in the way that you print, because it's going to be very crucial by the end result. So thank you. Subscribe and like this video, and we'll have more for you. Have a good day.